Hello everyone, you are watching Code with Shivajit, and today we will be solving one of the medium level problems from Geeks for Geeks, which is subarray with zero sum. So as the name suggests, we have to actually find whether there is a subarray among this given array, whatever array we have, that do we have a subarray in that whose sum is equals to zero, right? We actually don't have to return the subarray whose sum is equals to 0, but we just have to tell whether there is a subarray or not. That is, we have to return a boolean value with either true or false, right? So here we have the example 4 2 minus 3 1 6. I will actually go to the OneNote now to explain you this example only and the whole code flow. Okay, so I have indexed that and as well as written the whole array. Let's take this as ARR. Okay, so what we have to see here is there any subarray whose sum is equal to 0? So if you actually see this array, can you actually find a subarray whose sum is equals to 0? I can actually spot one subarray. Can you see that 2 minus 3 1 is a subarray whose sum is equals to 0, right? 2 minus 3 minus 1 plus 1, which is equals to 0. Okay, is there any other subarray here? Minus 3 1 6. And just to refresh your memory, that what is a subarray? Subarray means a set of contiguous elements in an array. Okay, a set of contiguous or continuous elements in an array. So in this case, 4 2 is a subarray, 4 2 minus 3 is also a subarray, 2 minus 3 is a subarray, but because they are continuous. But 2 1, this is not a subarray. Okay, we have to understand that, right? So now keeping that in mind, we actually have to return either true or false based on whether we have a subarray with zero sum or not. So the brute force approach which is coming to my mind now is, what we can do, we can just run a double for loop for this array ARR, where what we'll be doing, we will be just having I, which will be running from 0, I is less than n minus 2. Why I'm doing n minus 2? Because I will only go till here. I will tell you why. Okay, I plus plus. And then again I will inside that for j is equals to I plus 1, j is less than n. Okay, this should be n minus 1. This should be n minus 1, not n minus 2, because it's not equal to here. So it's my bad. It is n minus 1 because if n is 5, so n will be 5 here, right? Because the size of the array is 5. So what is 5 minus 1? 5 minus 1 is 4. So what is less than 4? I is less than 4. So the value of I will be till 3 only. So can you see the last element? It's 3 only. Okay. So j will be I plus 1. That is whatever I is. At that moment, the j will start from next to that element. J is less than n and j plus plus. And inside the double for loop, what I will be doing, I will be checking that from I till j, what is the sum? What is the sum of I till j? And if it is 0, if this is equals to 0, then I will return true. Okay. So just running through that, if our I is this 0th index, the value 4 I am taking, then my j value will actually go from index 1, index 2, index 3, index 4. Okay. So when j is at index 1, then what is the bounding range of I to j? That is 4 and 2, that is 6. The sum is 6. Is 6 equals to 0? No. So we will not return true. Then when j is 2, what is the bounding range? The bounding range is this 4 2 and minus 3. Is the sum now 0? No, it's not. Then j will come here, the bounding range is this, and then j will come here, the bounding range is this whole array. Now we will increment I, so I will become 1 now. So this is the I now. Okay, and now the j will start from here. Okay, j will start from here. So what is the bounding range of j initial value with 2? It is 2 and minus 3. 2 minus 3 is minus 1. No, not equals to 0. Now j will be incremented to this. So 2 minus 3 1. The bounding range of I to j is now 2 minus 3 1. Is it equals to 0? Yes, it is equals to 0. 2 minus 3 plus 1 is equals to 0. And as now it is equals to 0, I will be returning a true in such case. Okay. Now you can understand that if there is a zero sum subarray, then with this double for loop we will be able to find it, because we are actually traversing all the subarrays by this method, okay, and calculating the sum of them, and then whether the sum is 0 or not, based on that we will return true, okay. So this is the brute force approach, and that's why the time complexity which will be taken here is big O of n square, right? Because we have a double for loop here. Okay. So this is quite time consuming. If we want to optimize the solution to something better, then we might need to store some of the values in some data store, okay. Here the time complexity is big O of n square, but the space complexity is big O of 1, because we are actually not storing anything out of this array while looping out in the double for loop, and that's what makes it an optimized space solution but not an optimized time solution. So let me actually write this array again, and then I will explain you the optimized solution there, okay. So now we have to understand that how to actually uh, find the solution in big O of n, which is a more optimized solution than big O of n square, right? So I want you to focus on how a subarray is found, how a subarray sum is found mainly. What is a subarray? So if you take this subarray 2 minus 3 and 1, okay, so this subarray's sum is equals to 0, right? 2 minus 3 plus 1. There is one more way to find the subarray sum. What is that? That is, if we find the sum from here till the last third index, and if we have the sum from here, and if we subtract this part, then the sum which we will get is the subarray sum only. If you can understand what I am doing here, this is, let's say, sum 1, this is sum 1, and this thing is sum 2. If we do sum 1 minus sum 2, we will get the diff, and that diff will be the subarray sum only, okay. I hope you are able to understand that, right? Now going along the same direction, we can actually have a running sum over this array. Over this array we can have a running sum where it will actually whatever index it is, let's say if it is 0th index, then the running sum value will be 4. If it is index 1, then the running sum value will be 4 plus 2, which is 6. When the index is 2, the running sum value will be 4 plus 2 plus minus 3, which is 6 minus 3, which is 3 again, right? So this is the concept of running sum. Now why I am putting a variable running sum and why I am storing the running sum of this array while traversing it, there is a reason to that. As I have mentioned here, right, you can find the subarray sum by actually subtracting the sum 1 by sum 2. And what are basically sum 1 and sum 2? Sum 1 is the running sum when the index is 3. Sum 2 is the running sum when the index is 0. So if we are able to log the running sum at each index, if we are able to log that, then we will have the running sum at each point, here, 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 and here, okay. And with that, what will be helpful, I will tell you, okay. So what we can do is, let's say we are at this point, this index, okay, we are at this index, this is index 3, right? So the running sum till here, what it will be, it will be 4 plus 2 minus 3 plus 1. What is that? 4, 5, 6, 6 minus 3, 3 plus 1, 4. The answer is 4, right? Can you see something? 4 is also occurring here, right? So if you think a little bit more deep, you can understand that whatever running sum we are presently encountering, okay, if we check that have this running sum previously occurred or not, if that running sum has previously occurred, it definitely means that there is a subarray with sum 0. Why I tell that? Because the running sum of this 4 elements, that is still index 3, is equal to 4, okay. And if there is a running sum of 4 previously as well, which is for index 0, it means that whatever later elements are there which are actually adding up, they are adding up to 0 only. And you can check it from here as well. 2 minus 3 plus 1, that is 0. That's why I'm saying that the present running sum, if that running sum is already present, it means we have a subarray with 0 sum. Okay. And how will we check that if that present running sum is already present or not? Because as I have told, at each and every point I am logging the running sum. And how am I gonna do that? I will be actually having a map. Okay, I will be actually having a map where we will be having a key value pairs. And what are the key value pairs? I will tell you. This is a map actually. This is a hash map in Java where we have key and value pairs. Okay, where we have key and value pairs. Here the key is the running sum. Okay, that is the running sum at each and every point. Okay, and what is the value? The value is just the counter that how many times the running sum has occurred. Okay, if I loop over this array, okay, so what I will do, I will actually have a for loop over this array. Let's say for I is equals to 0, I is less than n, and I plus plus. Okay, I will be having a for loop over this array and what I will do, I will actually have a running sum which will be initially 0. Okay, and inside that what I will do, running sum plus is equals to the ARR of I. Okay, let's take this as array as ARR. Okay, fine. Now we will be doing the running sum plus is equals to ARR of I, and now we will check that whether this uh, running sum what we have currently like calculated, was it already present, that is the key is already present inside the map or not. If it is already present, it means there is a subarray. So, and we will return a true, and if not, then after that if condition we will actually be, so we have a if condition here. Let me write that. If sum contains key, okay, sum contains key of that running sum rs I am taking, if that is the case, then I will return true. I will return true. Okay, and if that's not the case, or after coming out of this if condition, what I will do, I will just put this running sum into the map. So what I will do, I will do map dot put, let's say I will put into the map the running sum with the value, the counter. Okay, the counter. What is the counter? The counter is uh, initially it will be 1 for the first time, and for the next time it will be the previous value plus 1. Okay, so for simplicity let's take it as 1 only, right? Now let's run through the array. So the initial index, that is the index 0 having the value 4. Okay, so the running sum is 4 now. Okay, let's take the running sum here. Running sum is 4 now. Running sum is 4. So do we have 4 in the key value map? As it is empty, there is no 4. So I will put 4 with a counter as 1. Now the running sum is 4 plus 2, which is 6. Okay, so do we have a 6 here? No, we don't have a 6 here. So I will put 6 and I will put the counter as 1. Now we have 6 minus 3. The pointer is here. Now we have 4 plus 2, 6, 6 minus 3, which is 3. Has 3 occurred before in the map? No. So I will do 3 and I will put it as 1. Now we have 1. Okay, we have this 1. So what I will do, 3 plus 1, which is 4. Now the running sum is 4. Do we have 4 in the array? 4 in the map? Yes, we have a 4 in the map. What it means? It means that there is a subarray in which a 0 sum is there, and we can actually see that, right? This subarray is there where 0 sum is there. 2 minus 3 minus 1 plus 1 0, because this 4 is already here. So in this case we will be returning it as true. This condition will be true and we will return from here. So that's the whole idea of this. Okay, what we are doing, we are actually having a running sum, as well as we are having a key value pair, a hash map, where we are storing each point of the running sum, so that we can understand that is there a subarray or not who is actually having that running sum somewhere before, so that we can understand, okay, now we have a subarray in between where the sum is equals to 0. Okay, so let's code this out whatever logic we have built, and then we will submit the solution, and then you will be able to understand how things are working. Okay, so let's go to the code part. Okay, so let's initialize the hash map first. So we have hash map of integer comma integer. Let's take it as running some map is equals to new hash map. Okay, I think this m should be capital. New hash map, this will be same integer integer. Okay, and okay, let me just do this, and this should be it. Okay, now what we have to do, the running some map is initialized. We will also initialize a running sum for the array as 0, and then what we'll be doing, we will be running a for loop in that over the whole ARR, and what we will do, we will add it to the running sum for the present ARR I value. Okay, and now we will check that whether that running sum has already occurred in the map or not. So what we will do, if running sum dot contains key, uh, what contains key? If running sum dot contains key, that's not the correct thing. It should be running some map, this one, because that's the hash map. Over that we are uh, like querying the contains key method, that whether this running sum, is it present as a key inside the running sum map. I also forgot to tell you one more condition. We also have to check that if our running sum is 0 or not, because it might be also cases where our running sum is only 0. I will tell you when. So if you take this condition, let's say if we have this array where we have this 3 and -3. Okay, in this situation as well, what will happen? The running sum is here 3. Okay, then -3 is encountered. What is the running sum here? It is 0. In this case also, we have a zero sum subarray, right? So to handle this case, we actually have to have this running sum is equals to 0 condition. And if that's the case, we will return true, because yes, we have a subarray with 0 sum. So we'll be returning true. Okay, after coming out of the if condition, what I will do, I will actually put this running sum with a value 1 inside the running sum map. Okay, and after coming out of this loop, if still the return true hasn't been called, it means that we do not have any subarray with 0 sum, so we will return false. If I tell you about the space complexity, it is big of n due to the hash map we are using, and if I tell you the time complexity is also big of n because we are traversing the array once. Okay, so with that, let me compile and run and see if it's passing the basic test cases or not. Yes, the output is coming true. I would highly encourage you to actually solve this problem on your own. You can also take some other random examples, dry run the logic on this, okay, and try to submit the solution and see that if it passes or not. Okay, so that's all for today. Thanks a lot. And if you have any doubts, you can put them in the comments, and I will be really happy to help. Thanks again.